Hey, all you fifth grade mathematicians out there. We're going to take a look at entry task day 96. We'll take a look at each problem. If at any time you're a little confused, you can stop the video and look back over what we're doing. And as always, you can contact your teacher via Seesaw or through Zoom meetings that we have with our office hours. So let's start with question number 1. As we read that, it says, which expression is equal to 24 over 8? Now we know that from our experience that 24 over 8, we would ask ourselves, how many 8s go into 24? So that tells us that it is also equal to 24 divided by 8. And we could also write that a third way. 24 in the house divided by 8. So all three of those are equivalent expressions. So as we look at number 1, the only one that would work would be C. Now some people might accidentally confuse A and C, but we want to remember as we read this problem, we read it from the top down, and we'll read the fraction bar as a division symbol. So we'll just say 24 divided by 8. Okay, let's look at problem number 2. Enter the sum. 4 6 plus 2 12ths. So we know that when we add anything in math, whether it's fractions or whatever, we have to have like units. In this case, a like unit would be a common denominator. So as I look at 6 and 12, I would count by 12, so count by 6s. I go 6, 12. At that case, in that point, we would just stop and say, okay, we know that the common denominator is 12. So mathematically, as we look at this, I would need to make that an equivalent fraction. So 4 6 is the same as 8 twelfths. 8 twelfths plus 2 twelfths. Now we have like terms or common denominators. So we add the numerators, and the denominator in this case stays the same. Now some of you might look at this and you might say, well, wait, Mr. Gilman, why couldn't we change the 2 twelfths into sixths? And we could. So if you're seeing that 4 6 plus 2 twelfths is the same as 4 6 plus 1 sixth, we can do that because we can make an equivalent fraction by dividing by 2. Divide by 2, right? So 2 twelfths is equal to 1 sixth, and we end up with 5 6. So for this problem, if you came up with 10 twelfths or 5 6, you were correct. Okay, on problem number 3, this is a problem involving volume, and we haven't covered volume yet. We'll be starting that up real quick in Module 5. But volume, we have 3 dimensions when we find volume. Let's read the problem. Elias is building a rectangular prism. The bottom layer of the rectangular prism is shown. He builds a prism that has 9 layers. So one of the things that we know, you all know how to find the area for a 2-dimensional where you have a length and a width, but a rectangular prism has a 3rd dimension. Okay, and so in this case, we're looking at, I'm going to zoom in here. We have a length of 5 centimeters. And we have a width of 2 centimeters. So two of the dimensions, we have 5 times 2. And then in this particular object, the one that the object that they give us, it has a height of 1 centimeter. But if we just went by what the picture told us, we'd do 5 times 2 times 1. However, look at this right here. It says he builds a prism that has 9 layers. So the height would be 9. So for me, as I'm looking at this, I'm like, okay, 5 times 2 is 10. And 10 times 9 is 90. Now, one thing to remember is that enter the volume in cubic centimeters. So we're going to write 90. And the way I do it is I put the unit, and then I put a little 3 there to show that it's 3-dimensional. That means centimeters cubed. Okay. Now, the next problem is also a type of problem where we haven't had a lot of, or probably have had very little exposure to graphing. But a couple things to remember. In this problem, it says use the graph and the figure to answer the questions. So when we are finding coordinates on a coordinate grid, we always will start at the origin, which is 0, and you always go over and then up. Okay, so I'm going to zoom back out here, and this tells us or it's asking us which set of ordered pairs shows the coordinates for A, B, and C. And I'm having some issues with drawing on this. Okay, I'm trying to zoom in. Okay, so what we're going to go with A first, and I'm going to write it over here on the side. And whenever I write a coordinate pair, I'm putting it in parentheses, and I will do the x coordinate first. This is the x. And then we will do the y coordinate. Okay, so here we go. We're going to start at 0, and we're going to count over 1, 2, 1, 2. And that puts us in line with A, so our x coordinate is 2. And our y coordinate, we're going to count up 1, 2, 3. So it's over 2 and up 3 from the origin. Okay, so let's do B. This time I'm not going to do loops. I'm just going to start at 0, and I'm going to count over 1 and up 1. So the x is 1 and the y is 1. And now we're going to do C. We'll start at the origin, and we're going to go over 1, 2, 3, x of 3, and we're going to go up 1, a y coordinate of 1. Okay, so now we have our coordinates, and we're going to see which of those is correct. So A says 2, x of 2, 3. The next one is 1, 1. The next one is 1, 3. Well, that's not it, because the very last coordinate pair is wrong. B, we have 2, 3, 1, 1, and 3, 1, and that is correct. And we're just going to check C and D. 3, 2, nope, that's not right. So all it takes is one of these to be wrong for the whole thing to be wrong. And that one has 3, 2. So yes, we have an answer B. Now let's take a look at part B here. It says select all the attributes that describe the angles found in this triangle. So let's do a little review of angles. We have a right angle is 90 degrees. right? An acute angle is, oh, it's so cute. It's less than 90 degrees. It's so little. And an obtuse angle is greater than 90 degrees. So as we look at our triangle right here, we see that there are no right angles. There are acute angles, but there are no obtuse angles. And in this particular problem, we're told to select all the attributes. In this case, there's only one attribute. So remember, if you have any questions about these, go ahead and ask your teacher. Keep your brains growing and keep learning.